panel that's assembling now has got, this is going to be an extremely important panel. And I began my talk about 2 hours ago with information on carbon in the atmosphere. We've crossed 400 parts per million. 412 to 415 have been recorded periodically. And so getting that back down to a safe level is crucial. I want to establish one fact, that there's roughly a 20 to 30 year lag between what comes out of our tailpipes and smokestacks and the climate change-driven weather effects that we experience. So all those storms and climate anomalies that we see in the evening news, that's not a result of 400 parts per million. That's really rather more like 370 parts per million. We don't know what 400 parts per million is going to do. So that's the background for this, this panel. Safety, Jim Hansen said once in a paper that it was 350 parts per million, but at 350 parts per million, we were already seeing melting of parts of the Arctic and lots of weather anomalies. It may very well turn out that safety for humankind is back down very close to the original or the background level of 280 parts per million. So that's the background for this particular panel. Bill Brandt has been up here before. He is a member of AREDAY's board. He's at Arizona State University, and it's very easy to give a plug for Arizona State University. It's one of the great universities, and they've been doing under Michael Crow's leadership all kinds of things about sustainability and research and so forth. And Bill is a Renaissance person if there ever was one. He's in the middle of lots of different kinds of things. His official title is Director of Strategic Integration. Would you welcome, please, Bill and this very remarkable panel.
Thank you for that wonderful introduction. A technology of the future is the topic of today's talk, and I'm going to introduce my colleagues up here who will be speaking and then say a few words before they start. Graciela Chichilnisky is the co-founder and managing director of Global Thermostat. She is the author of The Carbon Market of the United Nations Kyoto Protocol and communicated the concept of basic needs which in 1993 in the United Nations Earth Summit was voted the cornerstone of sustainable development. She has PhDs in mathematics and economics, studied at MIT and UC Berkeley. She's a professor at Columbia University and a visiting professor at Stanford University. She appeared in the 2009 Time magazine Heroes of the Environment and has received multiple corporate leadership awards. Klaus Lackner is the director for the Center of Negative Carbon Emissions and a professor at the School of Sustainable Engineering and the Built Environment at Arizona State University. His research interests include closing the carbon cycle by capturing carbon dioxide from air, carbon sequestration, robotics, and mass manufacturing. Klaus trained as a theoretical physicist and has made a number of contributions to the field of carbon capture and storage. His recent work at Columbia University as director of the Lenfest Center was for advanced innovative approaches for energy in pursuit of environmentally acceptable technologies for the use of fossil fuels. So we are here on this panel discussion about how we're going from ambition to action. We are being challenged as leaders to recruit volunteers and to engage them in missions that can get to the nitty-gritty of implementation. As we heard from the president of Iceland yesterday, Iceland was transformed to clean energy block by block. We also heard from Bill Donahue this morning about democratization and how we are creating new language for treating carbon as a resource and thinking importantly about the re in reuse and helping to create markets that are demanding, not waiting for new products. We've noted that companies are now setting goals for their supply chains, but the question is, how do they do it if the product isn't available? The World Business Council on Sustainable Development recently kicked off a program called Below 50. Below 50 stands for 50% less carbon than classic fossil fuels. And yes, it has 50% lower carbon. So how do you do this? Well, you have to grow a global corporate market. You have to increase the number of companies that are wanting carbon fuels. You have to develop a broad church for companies that can produce these low carbon fuels and their messages about CO2 reduction. As was pointed out yesterday, we also have a fossil fuel industry that's a significant part of our economy. And in principle, they will need, for example, to distribute these new fuels. But As a recent article put out by Bernstein, who are analysts for the stock market, said that the single greatest existential threat to the oil business is 2 degrees centigrade. So assuming this target, Bernstein noted that 35% of the remaining fossil fuels can be burned. So the elephant in the room is that in spite of the INDCs, the world is on track for something that's greater than 2 degrees C, unless we can move to a system where we develop and deploy systems that are effective in creating carbon sinks, and to add to the contributions that will come from no deforestation and improvements in agriculture. As David Orr noted in his remarks this morning, we don't want to be too late.
So I think I'll come here in a way with the good news that capture of carbon dioxide from the air in order to rebalance the carbon books is actually possible and feasible, and it's of course also worthwhile. I have been thinking for more than 20 years now about how to balance the world's carbon budget. I started this out in the early 90s in Los Alamos, and back then I was mainly thinking about mineral sequestration, of how to put carbon dioxide safely and permanently away. Later on, I got into the question, how do we actually get it back out of the atmosphere once it got there? And that question has, over time, become much more and more important. Back when I started, I sort of motivated myself with the simple observation that carbon dioxide in the atmosphere is sticky. If you think about it, and you have seen this actually on a slide half an hour ago, if you put a ton of CO2 into the atmosphere, roughly half of it goes away quite rapidly because it ends up in the ocean or in plants. The second half will be around for at least 300 years, 200-300 years before it gradually goes away. And that last quarter is with us for thousands, if not tens of thousands of years before it eventually goes away. So from a human perspective, we should think of this as a problem where things just level out. We have to put a ton of carbon in the atmosphere. We have to balance it out. It's literally like we charge on a carbon credit card, and as we keep charging, the debt gets larger and larger, and right now we say, we still have a lot of obligations we haven't really quite taken care of, and it will take us some time to start paying back on that carbon credit card. But we have no choice about it. In the discussion you heard earlier, which was sort of raised, is, okay, if we have to pay back, do we really have to pay it all back? And that's a possibility, that we can't settle things at a stable, comfortable point unless we go back to 250. Maybe the 350.org folks are right, and we can settle at 350. But back then in 1990, 92, 93, I didn't know that. And I said, maybe it's 450, maybe it's 550, maybe it's even larger. But it doesn't really matter. We have to, within a generation, get into a system where carbon is balanced in the system. If for every ton of carbon coming out of the ground, another one is put away again safely and permanently. We will have to end up with sequestration because we have to pay back an old debt. What we took out of the ground, we can't leave in the biomass because the trees get more than they were before. We have to figure out how to get to a complete balance. And part of this then raised the problem, how do I actually get it back once it's out? Yes, we can grow trees. But can we really grow trees at the rate of pulling 2 ppm a year systematically back for 50 years because we want to get 100 ppm back? That's about 1,500 gigatons of CO2. That is more CO2 than we emitted in the 20th century. Can we simply do that? Or do we have to figure out how to solve this problem by pulling actively back? And sort of in the time scale, I got interested in this question. I started to realize one day that it's actually feasible. This was in the late 1998 or so. And people were back then discussing how to do renewable energy with towers, cooling tower-like structures where you spray water out at the top, the air cools, falls through the towers, and you collect the energy. And I talked to a colleague of mine, a famous astrophysicist at Los Alamos, Sterling Colgate, who said, I had worried about this to scrub the ozone out of the atmosphere in Los Angeles, and I know how to design these towers. And I was asked whether it's actually feasible. But what struck me of the conversation is he said, these towers can collect 50 cubic kilometers, past 50 cubic kilometers of air a day. And I walked out of this meeting, I said, that's an awful lot of CO2 in 50 cubic kilometers of air. And I went to my office and I started to do calculations. I designed my own little tower. And I said, well, this is only 15 cubic kilometers of air, but still, it makes about 3 megawatts of electricity if I put these wind turbines around it. But it would pass the CO2 from a 360 megawatt coal plant. And that was, for me, the aha moment that I said, it's actually worth thinking about it. There is so much CO2 in the air, even though it's only 0.04%, that it's actually worthwhile going after it. And what I back then laid out is the idea we need to be passive, because we can't really afford to do all sorts of complicated things. And we have to absorb that CO2 on structures which are not unlike the leaves of a tree, except they are faster. 1,000 times faster, because they are designed to do nothing else but absorb CO2. And hence, we started to call it synthetic trees. So we started to work on this, and we inspired companies like Global Thermostat to actually get into this story. They use fans to blow the air. They use different sorbents than we do. Ours has the very nice feature that when it's dry, it really loves CO2, and it gives it back when you make it wet. So we have figured out how to make this happen. And I think the good news is we are now at the point where we can do this. A couple of years ago, Michael Crow, who was just mentioned, the president of ASU, managed to lure me from Columbia, where, by the way, he hired me before, to bring me to bring me to ASU and convince me to build a Center for Negative Carbon Emissions. And that, to me, is a fantastic opportunity. We have now a center whose goal it is to figure out how to create these negative emissions, and they're important. The IPCC, in its latest assessment report, has said just because the lifetime of CO2 is so long, because it is so sticky, we actually will need negative emissions in order to hold the line at 2 degrees C. I think if we go to 1.5 degrees C, we have to hold the line below 400 ppm, and that certainly will require negative emissions. So I think we just at the right moment decided to do this, and Paris with COP21 has actually set this ambition. We now have really no choice, in my view, but to do that. So the goal of the center is to do this in a public environment, in an open environment where we, in conjunction with private companies who are trying to do it too, can demonstrate the technology at a level that the National Academy will not say anymore, we can't say anything reasonable about it, we don't know what happens, because we don't know it yet. We need to have this working at a public center where we can make it work in the public domain. This is our goal, and this is the effort we are trying to put together. So to this end, we need support. We have built small units. They are sitting on the roof of our building. They are working. There's no question that they are working, but they are small. And if you talk to GM and say, build a brand new car, they know how to do it, but they will literally spend hundreds of millions of dollars to put every nut and bolt in the right place. We think we need to raise on the order of $10 to $20 million to accomplish a similar goal. So we can, in the public domain, accessible to outsiders who can kick the tires, and we can take the best ideas from everybody and say, here we built something that works for everybody. We then can engage as the center in the policy questions this raises and answers. We can discuss that and work on that. And of course, we want to work with enterprises who are in the same field and help them get to a good start and have a thriving economy around building all of this. So there we need your help, not only in raising those money, but also in changing the narrative. We hear a lot about we have to reduce emissions. In the end, CO2 coming out of the ground needs to be disposed of. This is ultimately a waste disposal issue, but from the perspective of the renewable energy, it is actually even better, because we can also, once we have this capability, create a circular carbon economy, where we take CO2 from the atmosphere, we take energy from photovoltaics, from wind, and convert that CO2 and water back into hydrogen and CO, and then make fuels. We can then fly airplanes with fuels which are not fossil. We have a balanced carbon budget, and we can work the system this way. And
so
then
Klaus, thank you very much.
Yes.
That's terrific. And that's probably a good segue for us to move to Graciela's presentation.
Excellent.
Yeah.
I'm so glad that you can do it and show a real example of a commercial application which actually will help the system grow. And what I am saying is we also need sort of the public domain side sit side by side and integrate all of this into one big effort, and that's where we are looking for support.
Great. So, Graciela.
Well, with the great advantage is that you heard Klaus Lackner speak before. And that's very important, because he was there before, and his work is marvelous. And what he said is exactly right. We need an effort on this area of carbon negative technology, because what I'm going to say now is true and is verified. According to the fifth assessment of the IPCC, only carbon removals at this point, because we procrastinated so much, can resolve the problem of climate change. Carbon removals require CO2 to be removed from air. You cannot take it from a power plant, because you would just make that neutral. You want to make it carbon negative removals. That's what carbon removals means, carbon negative. This may not be the right point in the morning to hear about carbon negative, carbon removals, and this may sound very technical. What we're talking about is cleaning the atmosphere of the planet. For that, you need carbon negative technology that remove the carbon from air. What you heard from Klaus, who is a marvelous speaker and a marvelous person too. So what I'm going to do is talk about the commercial effort that we have done. I am the CEO and the co-founder of Global Thermostat. This company now is on 5.5 years of existence, having started in 2010. We raised $31 million, and we are in the process of raising more. We have built 2 operating plants, and you are all invited to join us at the Stanford Research Institute on 333 Ravenswood Avenue in Stanford, California, Palo Alto, in Silicon Valley, where you can see the plant operating. And what you see there is a side picture of the plant. And I'm interested in the presentations this morning from the architects that spoke about beauty and design, because I agree with them. And we think this design is sexy. What do you think? That was a joke. Thank you for laughing. Okay, so next is, we already discussed that. According to the 5th assessment report of the UN Intergovernmental Panel of Climate Change, which is a scientific authority of the UN, and the 2015 Paris Agreement, carbon negative technology is now the only way to avert catastrophic climate change. Wait, I did not say that other efforts don't matter. They are extremely important, and we need to reduce emissions, and we need the efforts of all of us. We all need to work together. What I did say is that without carbon negative technology, all those wonderful efforts will not succeed. That's what the 5th assessment report says. They drove all the scenarios. I'm not going to show you the scenarios here, but I can show you if you want at any time. And in each of these scenarios, unless you remove the carbon that is already there, take it down, okay? We put it out, it had to go down. That's what Klaus referred to as circular use of carbon. It's true. Unless we take it down, which means take the carbon from air, now there is no solution to avert catastrophic climate change in most of the IPCC scenarios. Did I make the point clear? So what we are talking about here is not nice to have. It is great to have, but it's necessary. It's now necessary. This session is talking about what can resolve catastrophic climate change. This is why Bill said it's an extremely important session. I don't know if I'm giving justice to this session, or Bill or Klaus are. I think they are. But whether we do justice or not, this is extremely important because this is the only thing that can resolve catastrophic climate change now. And yet, we all need to work together. So, the company that I created, Global Thermostat, which was chosen by Fast Company magazine as the world's top 10 most innovative company in energy last year. And I was chosen as the 2015 CEO of the year. Answers this critical challenge that I just explained by taking the CO2 from air and profitably making it into products that are sold in the marketplace. And there is enough of a marketplace within the next 10 years to absorb all the CO2 that we are putting in the atmosphere, which is about 30 gigatons a year, into commercial uses on Earth. For what? Water desalination, biofertilizers, beverages, foods, greenhouses, biofertilizers, synthetic fuels, and several other applications, but the main one, the one that can absorb huge tonnage, huge amount of CO2 from air, is building materials. So that includes plastic, and it includes things like drywall, cement, metals. Metals? Yes, metals. If you look at the latest BMW car, it's made of carbon fibers, doesn't use metal anymore. So the use of carbon, as we heard earlier today, shows that this CO2 molecule that is producing the terrible catastrophic risk that we are facing may be the most useful molecule of this century. And we heard that before. We hear it from Klaus. You are hearing it from me. We're not crazy. It is in the wrong place. So let's bring it down, put it to work to increase the fertility of our soil, create drinking water, desalinating water, food, vegetables, building materials, and I want to say the way to do it, that's what's coming next, is one important way, is the products I just told you before. Shall I repeat them? Yes? So, water desalination, biofertilizers, synthetic fuels, beverages, food, greenhouses, and building materials, such as plastic, such as replacing metals, etc., etc. If you want me to remind you, because people say, what? CO2, what? You are using CO2 for what? Okay, that's what I'm telling you, okay? That's what we use it for. Now, what I didn't say, but I have to say that, is that it is possible now to build carbon negative power plants. So the structure that you saw before, which is about 12 feet wide by 15 deep by 35 to 40 feet high, it's just like a small building, is sitting right now in Silicon Valley next to a power plant of the Stanford Research Institute, and is taking the CO2 from the power plant and additional CO2 from air. The net result is that this plant, together with ours, at the Stanford Research Institute, which is the most prominent technology research camp in Silicon Valley, is carbon negative. It's a carbon negative power plant. It produces electricity while cleaning the atmosphere from CO2. Just the opposite of what power plants do in the world. Power plants are a $55 trillion infrastructure that 55 trillion, with T, as in Tom, $55 trillion infrastructure, that is the main culprit for emissions, human emissions. 45% of the human emissions are due to power plants that produce electricity. And that's why we have in our mind this tug of war between more development and a cleaner atmosphere, because it's true so far. But with these technologies, as Klaus explained and I'm explaining now, you can actually have carbon negative power plants. Anybody who's interested will get all the information, scientific and otherwise, from me. Just let me know. Now, the Kyoto Protocol, you will say, all of this is very good, Graciela, so just tell me, how do we get this done? Well, first of all, our company is now commercial, just as Klaus said. I'm not blaming Klaus. Klaus is not responsible for our company. But he said it would be nice to have a company. I am going to exceed my time. And I will do it with pleasure because of what you guys put me through. And you deserve it. I just wanted to say that the money to do all this is provided and is there from the carbon market of the Kyoto Protocol that I authored, which has already traded $175 billion per year by 2012 and reduced 30% of the emissions of the carbon market trading nations, which means we can now have economic development that cleans the atmosphere. And we have a commercial firm that shows it. What do we need to get there? We need global policy. Is it possible? Sure. We created the carbon market. The carbon market was trading fine. The Paris Agreement is lacking in carbon emission limits. It's nothing mandatory in it, but it's good intentions. But through the Clean Power Fund, the carbon market can supply 200 billion a year for 15 years, and that suffices to build between 10 and 30,000 carbon negative power plants that can remove all the CO2 that humans emit currently, which is about 30 gigatons a year. This was created in Copenhagen, COP15, and you will say, well, that's great, so where is it? Not so fast. It's partly there. The Green Climate Fund is what emerged from my creation of the Green Power Fund, which I gave to Hillary Clinton when she was the Secretary of State in Copenhagen. The Green Climate Fund is halfway there, and lots more has to be done, but at least now we created another international law, with the first one being the carbon market of the Kyoto Protocol, and now the Green Climate Fund. But we still need global policy. We need to add carbon emission limits to the Paris Agreement, because the Paris Agreement is just good intentions. It doesn't have anything mandatory in it. I'm not against good intentions. I'm just saying it's not enough. But carbon negative technology can also help with global policy. It's not just the technology. Why? Because with carbon negative technology available, you can take CO2 from air and transform it into dollar bills. You can make money selling the CO2. I already said for what? Water desalination, synthetic fuels, beverages. Is that happening? Yes. We have commercial demonstration plants as we speak being built. Carbon removals appear in the Paris Agreement in 4 articles that I myself introduced when I was in Paris last December. And it was not easy to do so, but we did it, together with the Rainforest Coalition nations. And these 4 articles have the explanation of how to take carbon negative technology and implement it into global policy that will resolve the problem, similar to the Montreal Protocol. But in the Montreal Protocol, the key thing that worked is that we were able to replace chlorofluorocarbons by another chemical that was also commercially viable. And that is what we need to do here, to find a way so that the removal of CO2 is commercially profitable and viable. There is an enormous unmet demand for CO2, and this documents some of that. I don't have time to go over the details, but I can do it. I'm going to try to finish soon because I'm conscious that this loss of my presentation is going to cause problems later on. The loss of my presentation was not my fault, but I apologize. This introductory video you will not be able to see because there is no time. There is also a Scientific American video that was done by Scientific American about global thermostat. And the picture that you see there is my co-inventor of our technology and co-founder of Global Thermostat, Peter Eisenberger, who played an extremely important role and who also credits Klaus with enormous learning from the work that he has done. So Klaus is very important to this area. The commercial value proposition is that you produce this way CO2 at the lowest cost. Is it scalable? Yes. We already have a plant that, when fully provided with the right monoliths and materials, can take 10,000 CO2 tons per year. 10,000 CO2 tons per year. And we have commercial plants being built right now for similar amounts. It's scalable because it's done like a windmill. So what you see in Silicon Valley is actually the single commercial unit. And then you put many of those together. It requires no transportation because we take the CO2 from air. So we can put one of our units in this room. It's a little bit big for that, but we can take a smaller one and take all the CO2. And it's carbon negative. I already told you the uses of CO2, but it doesn't hurt. Biofertilizers, industrial gases, food and beverages, building materials, synthetic fuels, seawater desalination. We have 5 commercial plants in the United States and in Europe, and 1 in Israel. We have received all these awards, which is absolutely great, that are listed there, but the awards are not going to solve the climate change problem. We have to actually scale it up, deliver it, and do it. This is the leadership. I should introduce my great colleagues here, Peter Eisenberger, Edgar Bronfman, our lead investor and our chairman, and there is many more people that are very fundamental for this enterprise. It's a team effort. It's a tremendous team. I'm going to finish in the next 30 seconds, so I'm just going to show you some pictures. This picture is an article you should read about the market for CO2 is flooded by demand. There is tremendous commercial demand for CO2. This shows the radical change that this type of technology, as Klaus explained, as I'm explaining, and there is others, is causing in this market. This is about how it works, and you are invited to come and see this plant, which we think is sexy, but I'm sure it can be improved. This is a demonstration, our first demonstration plant that we built at the Stanford Research Institute, our commercial demonstration plant built 2013, and this tells you something about the interior, and it's really very pretty. It's actually wonderful, and we will be very pleased to have all of you involved and come and see our plant. We will explain how it works. You can see it and touch it and watch it operating at Silicon Valley, and then we can decide how we're going to work together. Thank you.
Well, we're out of time, and I just want to thank you as an audience for understanding how we've had to sort of work through this whole process. So thanks very much. What I can say to you is, buy carbon fiber iPhone covers, buy carbon structural materials, and just help us create this demand for the carbon market, which is coming as part of the circular economy. And remember, we don't want to be too late, so it's all about scaling, and it's all about getting these technologies to market quickly.
Visit us next door.
And next door or in the other room, if you want to speak with Graciela or Klaus, please feel free to talk with them about your questions. So thanks very much.